Next, Latin square design, LSD, three-way classification problem, right? With shifting the origin. Analyze the following results of the Latin square experiments. Given 4x4 data, the letters A, B, C, D denotes the treatments and the figures in the bracket denotes the observations, right? So total number of items n is equal to 16. So number of rows, columns, that is equal to 4. That is n is equal to 4 here, not C or take it n, right? And defining null hypothesis, there is no significant difference between columns, and there is no significant difference between rows, and there is no significant difference between the treatments. Treatments is letters, right here, right? A, B, C, D. Note that, right? So alternative hypothesis, there is significant difference between column, rows, and treatments or letter. So shifting the origin to 15. So subtract 15 from each and every numbers given in the data within the bracket, right? So 12 minus 15, like that. 20 minus 15, 16 minus 15, 10 minus 15. You will get the revised numbers. So using these numbers, we are going to calculate further ANOVA. So rows R1, R2, R3, R4, and columns C1, C2, C3, C4. So we are using the revised data, right, from the previous table. So we are writing the details here, right? So now first find the row total. So row 1, so adding the all the numbers. So in the first row you will get minus 2, second row minus 3, and third row minus 1, and fourth row 2, right? So just add the numbers within the bracket, right? In the first row, minus 3 plus 5 plus 1 minus 5, right? You will get minus 2. Similarly for the second and third, fourth row. Similarly, add the column numbers within the brackets. So minus 3 plus 3 minus 3, 1. So you will get minus 2. For the second column, 0. Third column, 1. Fourth column, minus 3. Add either row total or column total, both should be equal, so you will get the grand total G, that is equal to minus 4. Then find Ri square by n. Normally we use Ci, right? So here Ci, Ri all are equal to n, which is equal to 4. So minus 2 square, R1 is minus 2, minus 2 square by 4, n is 4, that is equal to 1. Similarly, minus 3 square by 4, 2.25. Minus 1 square by 4, 0.25, and 2 square by 4, 1. Similarly for the column Cj, so just add the all the numbers in the Ri square by n. So you will get sigma Ri square by n, that is equal to 4.5. Similarly for the column Cj square by n. First column total is minus 2. So minus 2 square by 4, 1. 0 square by 4, 0. 1 square by 4, 0.25. Minus 3 square by 4, 2.25. Then add all the numbers in this. So you will get summation Cj square by n, that is equal to 3.5. Next, sum of squares, row. First row, square the numbers within the bracket, right, in the first row, and add all of them, right? Minus 3 square plus 5 square plus 1 square minus 5 square, so equal to 60. Similarly for the second row, 3 square minus 1 square minus 4 square minus 1 square, 27. For third row, 29. Fourth row, 42. Similarly column square, right? Column sum of square. So first you square the numbers in the first column and add them, right? Minus 3 square plus 3 square minus 3 square plus 1 square, 28. Second column, 42. Third column, 33, and fourth column, 55. So add the sum of squares either from row side or from column side, both should be equal, so you will get sum of squares, right? Yes, double summation xi square, xij square, so that is equal to ss, that is equal to 158. This is ss, right? Next, correction factor g square by n, that is equal to minus 4 square by 16, that is equal to 1. Next, table 2 for letters, treatments, right? So we are using letters there. right? That is why we are putting letters. So alphabets should be in order A, B, C, D, right? Then X, I, J. So you have to take the entries from the table 1, right? In order, proper order, right? First one, second one, third A, fourth A. Similarly B. First B brackets, within brackets, right? Minus 4, 4, minus 4, minus 5, 1, 0, 1, minus 1, 3, 5, 4, 5. Then find the sum of the first row total, that is Li. L1, L2, L3. First row total minus 6, minus 3, minus 1, 0, plus minus 2, right? Minus 6. Second row total, that is you take B. Minus 3 plus minus 4, minus 4, minus 5, 16. Then 1. Then last one, 17. That is minus 16, right? Then Li square by n, right? N is 4. So 9. So minus 6 square by 4, 16 square by 4, 1 square by 4, then 17 square by 4, 72.25. Then sum of Li square by n. So you will get 145.5. Next you have to find the total sum of square. That is formula double summation Xij, that is SS, right, in the previous table, right? Xij square minus G square by n. So you will get the details from the previous table. 158 minus 1, 157. Column sum of square, summation Cj square by n minus G square by n. From the previous table, 3.5 minus 1, 2.5. Row sum of square, sigma Ri square by n minus G square by n. 4.5 minus 1, 3.5. Then letter sum of square from this table, right? From the above table, summation Li square by n minus G square by n. So 145.5 minus 1, 144.5. Then error sum of square, TSS minus CSS plus RSS plus LSS. So 157 minus 2.5 plus 3.5 plus 144.5, you will get 6.5. Next we are going to ANOVA table. So source of variation, column, row, that is letters, that means treatment, and error, residual. Sum of squares, column we know CSS 2.5, RSS 3.5, LSS 144.5 and ESS 6.5. Then degrees of freedom C minus 1, that is n minus 1, 3, and this is also n minus 1, 3, and this is also n minus 1, LSS, right, 3. Then this is n minus 1 into n minus 2, 4 minus 1 into 4 minus 2, that is equal to 6. Then mean sum of square column 0.87, formula is CSS by V1, right? Then row sum of square, mean row sum of square, RSS by V2, 1.167. Then mean letter sum of square or treatment sum of square, LSS by V3, 48.17. Then mean error sum of square, ESS by V4, 1.08. Then F ratio. So taking column sum of square and error, right? First ratio. Second ratio, row sum of square and error, right? And third ratio, letter sum of square and error. You have to take error, you have to compare with the error only in the ratio, right? First column FC. So just to check MCSS and MESS. MCSS is 0.87 and MESS is 1.08. So you have to write the greater number in the numerator whenever you are writing the F ratio. So 1.08 by 0.87. So the formula is MESS by MCSS, that is equal to 1.24. Next you take row FR. So compare MRSS and MESS. MRSS is 1.167, which is greater than MESS 1.08. So you have to write MRSS in the numerator and MESS in the denominator, right? So you will get 1.082. Next MLSS. Compare MLSS and MESS. MLSS is 48.17, which is greater than MESS 1.08. So you have to write MLSS in the numerator and MESS in the denominator, FL. So you will get 44.60. Next conclusion for columns, degrees of freedom V4, V1. Whenever you are writing the degrees of freedom, first write the greatest one, then the smallest. That is numerator degrees of freedom and denominator degrees of. So V4, comma V1, 6, comma 3. So tabulated value of 6, comma 3 at 5% level, FT tabulated value, right, 8.97. So compare FC and FT. So FC is less than FT, therefore null hypothesis 1 is accepted. Next rows, degrees of freedom V2, V4, right? Here V2 is greater than V4 because MRSS is greater than MESS. So at 5% level, 3,6 degrees of freedom, FT is equal to 4.76. This is from the F table, statistical table. So calculated value of FR is equal to 1.08. So 1.081 is less than 4.76. Therefore, FR is less than FT. Null hypothesis 2 is also accepted. Next, treatments or letter. Degrees of freedom V3, V4, 3, 6. So tabulated value at 5% level, FT is equal to 4.76. Then the calculated value we know 44.64 from 60 from the table. Compare FL and FT. So FL is greater than FT, therefore null hypothesis 3rd is rejected, right? Thanks.